Welcome to the Flowgrid Regulator product training video. In this video, you will gain an understanding of the Flowgrid Regulator and its recommended operation. The Flowgrid Regulator is a valve used to control the pressure or flow of almost any gas or liquid. It is a self-contained pilot-operated device that can be used in pressure reducing, back pressure, and other applications. The Flowgrid Regulator assembly consists of two main components, the valve body and the pilot assembly. The valve body controls the flow of gas from the upstream system to the downstream system. The pilot assembly is the controller or brain of the device. It measures the pressure in the downstream system. It also provides the proper loading pressure to proportionally control the flow of gas through the valve body. In this video, we will focus on the basic principles of operation, installation, maintenance, and troubleshooting for the Flowgrid Regulator. Here are the Flowgrid principles of operation. The Flowgrid consists of a loading chamber, a diaphragm or throttling element, and the pilot assembly. The pilot assembly consists of the fixed orifice and a variable orifice. The pilot regulator is basically a self-operated regulator. The combination of the fixed and variable orifice comprises a pneumatic amplifier. The pilot controls the Flowgrid through three stages of control when configured for pressure reducing mode. 1. Fully closed. 2. Partially open. And 3. Fully open. The fully closed position occurs when there is no demand for gas in the downstream system. The pilot supplies full inlet pressure into the loading chamber of the regulator. When this happens, there is a zero differential on the inlet side, and therefore a zero force trying to lift the diaphragm up on the inlet side. There is, however, a full differential pushing the diaphragm down, closing the diaphragm on the downstream side. The partially open position occurs when there is an increase in demand for gas in the downstream system. This increase in demand causes a decrease in pressure in the downstream system, which is sensed by the pilot. The spring in the pilot then partially opens the variable orifice. As the variable orifice opens, pressure from the loading chamber of the regulator escapes to the downstream system. The decrease in loading pressure allows some of the higher upstream pressure to flow through the regulator. This satisfies the demand and maintains the pressure of the downstream system. The fully open position occurs when there is a large increase in demand for gas in the downstream system. In this situation, the pilot and regulator act much in the same manner as in the partially open position. The difference, however, is that the variable orifice will fully open, reducing the loading pressure to practically the same level as the downstream pressure. This allows for full differential between the inlet and loading chamber, allowing for maximum flow through the regulator. The next most common use for the Flowgrid regulator is in the back pressure or relief mode. To convert the Flowgrid from pressure reducing to back pressure mode, simply change the pilot sense line from downstream to upstream and change the pilot's valve orientation. Details about configuring the pilot for use in back pressure mode will be provided in the Series 20 pilot training video. In the back pressure mode, the Flowgrid remains completely closed until the set point of the pilot is reached. When this occurs, the pilot's variable orifice begins to open and releases some loading pressure to the downstream pipe. This decrease in loading pressure allows the diaphragm to partially open, therefore relieving some of the upstream pressure to the downstream pipe. Additional increase in inlet pressure may eventually cause the Flowgrid to go into a fully open position. When the upstream pressure increases enough to fully open the pilot's variable orifice, the maximum amount of pressure will be discharged from the loading chamber. This causes the regulator's diaphragm to be fully opened and allows the maximum amount of gas to pass from the inlet to the outlet of the Flowgrid regulator. A decrease in inlet pressure will allow the Flowgrid to return to its partially open or fully closed position. Now that we've covered how the Flowgrid regulator works, we'll show you how to properly install it. First, make sure you received all the proper parts with the Flowgrid. You should find enclosed with the regulator a serial card with the serial number, a parts list for the regulator and pilot if equipped, and an installation, operation, and maintenance manual. Inspect your regulator for any signs of damage. This includes any tubing and pipe nipples that have been installed by the factory. Verify that the serial number and pressure rating on the nameplate are correct. Also verify that the ratings, which are stamped into the flanges, and the capacity, which is stamped into the spacer, are also correct. Before installing the flow grid, please follow these general rules. Installation must be performed by qualified personnel and in a safe location. Verification of pressure rating and valve orientation is necessary. Verify the pressure rating by looking at the nameplate of the valve body. The pilot has a separate nameplate that verifies the pressure rating of the pilot as well as the spring range. The flange rating is stamped into the edge of the flange itself. To verify the correct direction of flow for installation, please refer to the stampings on the top of the spring case that identify the inlet and/or outlet. Locate the pilot sense line properly. The sense line should be installed 8 to 10 pipe diameters away from the regulator in an area of low velocity gas. It should be located away from any valves, reducers, or elbows that can cause turbulence in the pipeline. The pilot vent connection is located on the spring case of the pilot. If the pilot is located above ground, we recommend the vent be pointed down to allow for condensation to drain. If the pilot is installed below ground or in a building, the pilot vent should be vented via tubing to a safe location. Ensure the lines are purged and all connections have been leak tested before proceeding with startup. It is important to note that the Flowgrid regulator is rated for the same amount of pressure on the outlet side as it is on the inlet side. The pilot is rated for 1500 psi inlet and 1000 psi on the sense line connection. This means that there is little chance of damaging your flow grid upon startup or shutdown. The following procedure for startup, tuning, and adjustment can be used or modified for your application. Open a small vent valve downstream of the flow grid to establish some flow. Next, remove the closing cap from the pilot and back off the adjustment screw until you have a 0 setting on the regulator. Slowly open the inlet valve to allow pressure to enter the station. Turn the pilot adjusting screw in until you establish a small amount of flow through the downstream vent valve that was opened earlier. Continue to turn the pilot adjustment screw in until you reach the desired set point of the relief valve. Close the downstream vent valve. Set the relief valve at this point. Reopen the downstream vent valve. Adjust the regulator down to the desired set point of the regulator. Adjust the gain of the regulator by adjusting the restrictor. If the outlet pressure from the regulator is unstable, adjust the restrictor setting. After adjusting the restrictor, readjust the pilot adjusting screw to achieve the exact outlet pressure you desire. Lock the pilot adjustment screw and replace the adjusting screw cap. Close the downstream vent valve. The regulator is now set for service. Changes to the restrictor setting affect the accuracy and sensitivity of the regulator and will cause changes in pressure and speed of response. For example, closing the restrictor causes a slight increase in the outlet pressure, with the opposite effect when opening the restrictor. Also, the more closed the restrictor is, the slower the regulator will close, with the opposite effect when the restrictor is more open. Here is the standby monitor startup procedure. Start by setting the operating pilot at the maximum setting. Next, set the monitor pilot to the minimum or 0 setting. Slowly open the inlet block valve. If necessary, purge any pressure in the station. Full inlet pressure should be present at the monitor regulator, and the monitor regulator should be closed. Next, open the downstream block valve or vent. Increase the pilot setting on the monitor regulator until the desired monitor override setting is reached. Lock the pilot setting. With some flow going through the station, start to lower the operating pilot setting of the operating regulator until outlet pressure is achieved. Working monitor startup. Purge the station and open outlet valve or vent to allow for flow through the station. Set the pilot on the downstream regulator to a high setting above the desired set point. Next, set the pilot on the first regulator to a high setting above the set point. Then, adjust the monitor pilot to a 0 setting. Ensure that the restrictor on the first regulator's pilot is set at an intermediate setting of number 4. Slowly open the inlet block valve to the station. The first stage regulator should remain closed as a result of the monitor pilot being set to 0. Increase the setting of the monitor pilot to the desired pressure setting. If the valve is unstable, increase the restrictor opening until it becomes stable. Lower the set point of the downstream regulator to the desired outlet pressure setting. Tune the restrictor on the downstream regulator at the same time. The upstream regulator should open, or begin to control the interstage pressure at the set point of the upstream regulator's pilot. Adjust the set point of the upstream pilot to achieve the desired interstage pressure. Tune the restrictor on the upstream regulator's pilot at this time. Return the set point of the downstream regulator to the desired outlet pressure. Once the Flowgrid regulator has been installed and is up and running, you'll need to perform proper maintenance. The first thing you should do is check the regulator station itself for any obvious mechanical damage. This includes the piping, the regulators themselves, any sensing or discharge piping, relief valves, etc. The next step is to go through a routine checklist just to ensure that the regulator is functioning properly. It is necessary to establish flow through the regulator station while observing the outlet pressure gauge to ensure the regulator is controlling at the set pressure. The next step is to remove the closing cap from the pilot and adjust the set point of the regulator to ensure that the regulator responds to changes in the set point. Finally, you should vary the flow rate through the regulator from a high to low flow rate to observe the outlet pressure gauge. This ensures that the regulator is responding to increases and decreases in flow and controls at the set point. There are 2 procedures that you can use to determine that the regulator will shut off and lock up properly. The first procedure is to establish flow by opening an outlet valve or vent valve, checking to make sure that the regulator is controlling at the set point. Then, close the outlet or vent valve and observe the outlet pressure gauge to ensure that the pressure does not go above the lockup pressure of the pilot. You will have to wait an appropriate length of time to ensure that the pressure does not build up over the lockup pressure. If pressure builds up, then there is a leak. If the pressure remains stable, then the regulator has shut off and is locking up properly. The second procedure that you can use to verify lockup involves removing the closing cap from the pilot and backing off the adjustment screw until the spring force is fully relieved. This closes off the pilot and main valve. You can then open the downstream vent valve and blow off the pressure in the downstream system. Once the downstream system has completely vented, check for any leakage through the vent valve. Now we will discuss a method to determine that the relief valve operates and opens properly at the set point. First, you need to increase the pressure to the relief valve and listen for the relief valve to open. If the atmosphere is very noisy, you may use a bubble bottle to determine the exact opening point of the relief valve. An efficient way to increase the pressure is to go back to the upstream regulator and increase the set point of the pilot. Next, decrease the upstream regulator set pressure until the relief valve shuts off. Check for leaks. If any leaks exist, there are 2 potential leak paths, through the pilot or through the regulator body itself. Finally, remove the interconnect tubing between the pilot discharge and the regulator body and check for leaks. This enables you to determine whether the leak is from the pilot or the regulator. The final check involves checking all fittings for leaks. Use a commercially available leak detection product on all piping connections on regulators and relief valves to ensure that there are no external leaks. Now that we've gone as far as we can with external inspections, let's move on to disassembly and internal inspection. Remember to make certain that the pipeline pressure has been shut off and vented before beginning any internal maintenance work. Disassembly and maintenance of the pilot will be covered in the Series 20 pilot training video. To start the disassembly process, depending on your configuration, remove sensing line tubing, pilot supply tubing, and discharge line tubing. Remove the pilot closing cap and back the adjustment screw out to remove tension from the pilot main spring. Remove the bolts holding the spring case to the regulator body. Remove the spring case. Remove the main spring. Remove the diaphragm. Remove the spacer. Remove the throttle plate. Remove the body seal. Inspect the body for dirt or debris. Use a cloth and solvent that's compatible with nitrile-based rubber and wipe off the body, paying special attention to the O-ring groove. Rust can be removed with emery paper, after which use the rag and solvent again to clean any residue. After cleaning, you can begin to reassemble the regulator. Start by inspecting the body seal. Ensure that it is clean and is free from cracks or deterioration. If there are any signs of deterioration, replace the body seal. Next, insert the body seal into the regulator body. Ensure that the seal protrudes above the surface of the body. It should protrude from the body by roughly 20 thousandths of an inch. This provides for a proper seal of the mating component. Next, clean the throttle plate. Reinstall the throttle plate. The next step is to inspect the diaphragm and spacer. Make sure that the diaphragm is clean and free from any defects or deterioration that might prevent proper sealing. If there are any visible defects, replace the diaphragm. A used diaphragm may have the grid pattern imprinted in the rubber. You may wish to rotate the diaphragm 180 degrees upon reassembly, so the smooth side of the used diaphragm is now in the downstream side. Following the diaphragm installation, you will want to inspect the spring. Ensure that there is no damage or cracks, paying special attention to the spot welds. The next step is to replace the spring case. Note that the 1-inch, 2-inch, and 3-inch spring cases have a diaphragm guide built into the outlet side. Ensure that the diaphragm guide is installed on the downstream side of the regulator. Replace the bolts and torque to the value that is noted on the nameplate using a crisscross pattern. The next item to inspect and clean is the restrictor. Loosen the bottom cap on the restrictor and push the rotor and O-ring out of the restrictor body with a punch or similar tool. Clean both the rotor and the body. Inspect the rotor O-rings and replace if necessary. Lubricate the O-rings if necessary before reinstalling the rotor back into the restrictor body. Tighten the rotor assembly. Sense line tubing, pilot supply tubing, and discharge line tubing can all be reconnected at this point. The regulator can now be pressurized. Check for leaks and readjust the pilot setting as necessary. The regulator can now be brought back into service. We'll now cover troubleshooting tips for some field issues that you might encounter. The first steps in troubleshooting your Flowgrid regulator should be: verify that the regulator specifications fit the application conditions. The minimum and maximum inlet pressure, control pressure range, and minimum and maximum operating differentials should be checked to make sure the valve and pilot are designed to operate in the present conditions. Verify the regulator is piped properly. Check that current piping connections match the recommendations shown in the installation, operation, and maintenance manual. Verify the regulator is sized correctly. Regulators operating below 10% or above 80% of their maximum capacity, given current application conditions, tend to have more problems. Consider reduced capacity trim or a larger regulator in these cases. Another problematic field issue is the regulator does not shut off. In this case, refer to the failure mode chart to diagnose potential causes. Clean or replace valve and pilot components as necessary. Erratic control. If you are experiencing erratic control of your flow grid, then you should check for the following. Check for damage or debris in the restrictor and control pilot. Replace, clean, and lubricate components as necessary. Consider pilot supply filtration with a Mooney Type 30 filter. Check for the potential of hydrate formation or freezing liquids in the pilot system. If liquids are present, consider gas conditioning before the pilot and/or valve, heating the supply gas to the regulator, or heating the pilot supply gas using a pilot gas heater. Check the sense line location and be sure it is away from turbulent locations. Moving the sense line to a new location often solves control problems. Check to make sure needle valves are not used on any pilot system connections. Full opening type valves are recommended. Check for pilot vent port blockage. If you are having instability and speed of response issues with your flow grid, then you should check for the following. Change the restrictor setting. Refer to the startup and operation portion of the IOM manual. Check the sense line location and be sure it is away from turbulent locations. Moving the sense line to a new location often solves control problems. Check to make sure needle valves are not used on any pilot system connections. Full opening type valves are recommended. Check for pilot vent port blockage. If your regulator will not regulate to the set point, then you should check for the following. Check for proper sizing. The regulator may be running out of capacity during peak demand periods. Adjust the restrictor to a higher gain or a smaller setting. Refer to the startup and operation portion of the IOM manual. This concludes the basic principles of operation, installation, maintenance, and troubleshooting training video for the Mooney Flowgrid Regulator.